goal of this lesson are three goals are there. The first, we will try to understand what is the basic idea behind electric current. The secondly, we will discuss why and how to measure it. And finally, we will discuss why do we need electric circuit. That's all. We proceed with the very simple ideas and some basic question that will motivate you to read and study and to have the knowledge of the current topic, electric current. You will have a very question in the mind why we are concerning so much about electricity, why we are learning so, and that's I'm going to give the answer. See the world. We look at the world around you, the modern world. It is entirely based on electricity, that is electric current. All the devices that we use like TV, fridge, fan, heater, electric bulb, electric cooler, AC, mobile computer, and so on. The list is just countless. All are based on electricity. All uses the energy which is called electric energy. That's related to electric current or provided by electric current. Today's world cannot be imagined without electricity. If there is no current, simply there is no model. So it's very important. The secondly, electricity is the only form of energy that can be very easily converted into other forms of energy like heat, light and sound. I give you some very simple examples. Look at the electric heater. It converts electricity into heat energy. Similarly, look at the bulb. The bulb converts electricity into light. Similarly, sound system like loudspeaker convert electricity into sound energy. So it's magnificent here. One thing I give you, and you may have a question in your mind, why it is so? Why electricity can be converted into all these forms of energy? An answer is very beautiful. But you cannot understand this because your level is not that high. You will learn these in higher classes, but I give you the answer. Just you keep in the mind, don't get puzzled over here. The answer is here, the electricity, light, heat, sound, and whatever the energy which we're talking here are not different. They all are same. They belong to the same family of energy which we call electromagnetic vibration. The difference is there only in their frequency. All are same. They are not different. Also, one important and big advantage with electricity is that it can easily be transported over very long distances. And also, look at your body. Your nervous system, it works completely on electricity. So it is like a small power system. Electric current possibly present reason behind all the happenings, all the changes from very small scale to very high level in the galaxy are present. So electricity is essential and embedded in nature everywhere. Everywhere means everywhere, biologically, chemically, and all physical phenomena. So it's a must important topic. It's the initial topic, starting topic. That is the basic for the topics which you learn in this course and higher things. Okay, so far so good. Not at all problem here. We understood these things. Now return to the basic question. What is electric current? Well, this question is very simple. Defining electric current is simple and easy because we are already familiar with the term current in our daily life. For example, air molecules moves or that flows, we say wind or air current. So water flows in river, there in the water bodies, we say water current is there. Similarly, in any material or any matter, when charged particle flows, electron or positive charge or anything, for this chapter, the conductor is solid, so electron will be the moving part. Where the charge flows through a material like conductor, we say electric current is formed, or this is electric current. Simple basic idea, the flow of charge is we call electric current. Here one thing I want to give you in mind, whenever the flow of charge is referred, it refers only the flow of positive charge, not electrons. A reason is historical that when the electricity was discovered, electron was not discovered, and it was assumed by the scientists that the flow of electricity is just due to the flow of positive charge, not electrons. So it is a historical reason. Here a basic question arises that What is special about current or flow of charge? Why it is necessary that charge should move? Why it is so essential that? To answer this question, we have to take a look. We have already discussed the devices that use electric current. Now focus on the point these devices do with electric current, and answer is very simple. They uses the energy present with the current, that is charge. So they are using the energy which is called electric energy. But here we also know that here this electric energy is present in the field of the charges, that is the potential energy that is associated with the charge or the field. This is not the energy which is moving energy, so not kinetic energy that will itself moving in all direction and that will give the devices energy to work. It is a stationary energy, it's not a moving energy. And because of that reason, to utilize this energy present in the field of the charge, we have to move the charge through those fields. That will take the energy from those fields and that can give to the devices to work that, and therefore the moving of charge is very essential. Now okay, so we understood here, but here is a big problem, and problem is that charges inside a conductor or anywhere doesn't move itself. Now you have a question, why it is so? Why does charge not move itself? And the answer is that because there is no external force on the charge. There is no force on the charge on the conductor, inside the conductor, and because of that they don't move. Take a look for better understanding here. Inside electron called thermal energy, which we are getting from the outside. Because of that, the electrons move in randomly in any direction. The direction of their motion is just random. It's not fixed. It can be any direction. When they move, they get collided with the positive atom nearby present back to the same starting point, and because of that their net displacement in a given direction is always zero. Therefore no velocity, that is they are not moving, there is no current, and because of that there is no energy available to the devices. Therefore device will not work if the charge is not motion. So we understood this things here, and this thing is very similar to the motion of gaseous molecule in the gaseous state, that we already know that here. Okay, so we understood that charge is not moving in the conductor. So what is the solution? And solution is that we have to exert external force on the charged particle to move. Now, how it is possible? Yes, it is possible. We can do so by adding a battery or cell to the conductor that can exert force on the charge to move here. Now we discuss. This is a battery here. In this cell, by chemical reaction or by other mechanism in other types of battery, positive charge and negative charge are separated here by a chemical reaction. The charge gets separated. Positive charge move to this side and negative charge move this side here, as can you see here. This battery or cell has to do some work for this, that we will discuss later here. This side, upside and downside here, where the charge gets accumulated or charge gets deposited, are technically called terminals. So it is a positive terminal and it is a negative terminal here. Now it's a very interesting thing happen if you note that here. Now see here, it is a place where positive charge is present, and here it is a terminal where negative charge is present. So these are the charged, positive and negative. So it has a field around it. It also has a field around it. So there will be positive potential energy associated with this charge, which can be utilized. Similarly, here is a potential energy, negative potential energy is present here or can be utilized here. So it is like a fuel. So our fuel is ready that we can use here to convert this energy, which is potential energy, into kinetic energy of the electron that can give energy to our devices where we can use here. So let's do that here. So let's connect our wire, conducting wire, for make it to utilize it here. Now we have electric system, we have connected conducting wire, you can see here, and because of that what will happen, the electron will get repulsion from this side and attraction from that side. So electron will move from negative terminal to the positive terminal, whereas positive charge will move from positive terminal to the negative terminal. Here importantly, there is no positive charge here. We just assume because of historical reason, as I told you already here. Okay, so now you can see that how the potential energy which is present here and negative potential which is present here are utilized by these electron as their kinetic energy, and so now potential energy has converted into kinetic energy, or we can say this energy present in the cell terminals are now ready to converted or utilized by the devices here. Now, one important thing I want to tell you here, you now see in this path along with the charge can move, we give a special name to this because it plays a very important role. Without this, the motion of charge not possible, so current will not generate here. We call this closed and continuous path electric circuit is a very importantly here. Now, so our electric system is ready, energy is ready to deliver here. So now we can connect any kind of devices to this, let's say connect our electric bulb that will use this electric energy to give us light and heat here. So we have an electric circuit, we have a connected lamp and switch to control the current in this circuit here. Now this lamp will utilize the kinetic energy of the electron and convert into light energy. Again telling you here, electric energy, light and heat all are the same form of energy. They are not different as you will learn here. So everything here is crystal clear. So this is the basic idea of the electric current. We discuss a very important question here. What is the actual motion of electron inside the conductor? Think about this. It's a very interesting question. Does electron move like us? Does these moves like animals? Does they move like a aeroplane moving in the air? Or the like birds? Or like the vehicles or the car runs on the road? What do you think that here? Tell me in the comment box here. Now I will tell you here. This is not so. The actual motion of electron inside the conductor, it is like something which you have never imagined before here. We will discuss here a basic idea about that, but actually we will learn in the higher classes here in the domain called quantum physics. As I already told you here, electron inside the conductor have thermal energy, and because of that they randomly in any direction they move. That is not fixed here, and because of that they get collided with the positive atoms present around that, and this velocity with which they move is very fast per second, which is approximately 1% of the light, which is very fast here. But because of the collision they get back to the same point they started from, and because of that there is no net displacement, so there is no average velocity becomes zero, so current becomes zero and there is no energy available for the use. This is there when we connect these conductor to the battery terminals, the force applied is called electric force, or the field applied is called electric field, and then electrons move a force toward the positive end of the conductor and they have to accelerate that. But because of the frequent collision, their velocity get reduced very significantly and they move very less displacement, and that is just 1 millimeter in every second. It is a very slow velocity. Now we have question that if the velocity of electron is so small, that how it is possible that when we switch on or switch off the bulb or any devices instantly works? How it's possible? And answer is amazing. That's all about. That's why I tell you physics is so beautiful. And answer is that these devices does not use electrons, which is as particles, but they uses energy which is present with the charge, which is called its kinetic energy. And this energy which I already told you is electromagnetic vibration that moves with the speed of light, and that's why it is possible to work so instantly here. I hope you got the idea. Here, how do we measure electric current? This is very important because if we cannot measure the electric current, then we cannot use that. So it's a very important so that we can measure the current here. So we are going to discuss about that. How can we measure the current here? Now see here, the measuring of current has two aspects. First, about the charge, and second, how fast that move here. To understand this, take a look here. We have a picture here, which is a conductor here, and we have taken the total area, which is called cross-sectional area. Here we will look at how much how the charge is flowing throughout or coming out of this here. Now we fix the time 1 second or unit time because it helps us in measuring here, and then we see that simply how much current is passing throughout that. Okay. Now the amount of current that is passing through this cross-section area in unit time or 1 second simply, that will be our current here. So we can write here the electric current is the just amount of charge in 1 second. So simply I equal to Q in 1 second. But in general we will write I equal to Q over T. Okay, T for any time. In general we measure that here, but it is a per unit time. This symbol, that is a 1 second, always will be in final answer here. Let's repeat this formula. What this formula says us here. Now this formula says about two things. First about charge, and the second thing about time here. It tells us that charge is the source of current. If the charge is 0, then current also will become 0. Okay, and if higher the charge, then higher will be the current, and lower the lesser the charge, lesser will be the current also. Now the second is about time. It's also very important. Time telling how fast the charge is moving. If the charge is taking more time, that means it is moving slowly, and because of that current will be lesser, and vice versa. And because of that, current and time has an inverse relation. And one thing I want to just tell you here, both of things, charge and time, are affected by many other factors that we will discuss in later in this section, in this chapter here, in the next video here, which are coming here. And definition of current is precisely based on this formula because it is a more accurate. So the proper definition of the current is that the time rate of flow of charge through any cross-section area of a conductor. I hope you understood this one. Now take some more things. What is the, in what unit we measure current? And we measure the current in some unit which is called ampere, in the honor of André Marie Ampere, which was French scientist or physicist which did a lot of work in this regard. Now we will define unit of current. Now the question is why we define unit of current, and to answer this question, take a look deeply here. Think about it. We have discussed that the basic idea behind the electric current is to use the energy present with the charge here, that is called electric energy, right? We have discussed that. Now also we know that here this energy is potential energy which is present with the field of the charge, which is potential energy, right? And how we by doing work on 1 coulomb, positive 1 coulomb charge, right? That was, we discussed that. Similarly, it is a very obvious question that 1 coulomb charge, which we have taken as a defining electric potential as energy, when moved, how much current that will form, and that is we call definition of electric current. So we know that in SI unit, the SI unit of the current is ampere. So whenever plus 1 coulomb charge, which is standard test charge we take here, and passing through cross section in 1 second, then how much current it will be? That is called 1 ampere. This is our definition of ampere. So 1 ampere is the current when 1 coulomb, 1 positive coulomb of charge moving in 1 second, and it is the huge number of electron that is present in there. This is 6.25 to the power 18. It's a very huge quantity. Now take the next here. What type of quantity this current is? It's a scalar quantity because its measurement does not involve direction. Now you may have a misleading idea because the wire has the length, so you can think about the direction, but you can correct your intuition by just bending the circuit or the wire. Then you will find that there is no change in the current. So bending wire, that is direction, does not affect the current, and that's why the current is a scalar quantity. Now we discuss about direction of current. Direction of current is always from positive to the negative because we take the flow of positive charge because of historical reason as the direction of the current. That's why direction of positive charge is taken as the direction of current also. So direction of current because of historical reason is from positive to negative, but in reality we know that it is the negative to positive because of electron, which is the actual charge inside the conductor or region of the current here. Now finally we will discuss about the measuring device. The device by which we measure is ammeter. This is the picture of this one. We will discuss working in the later section here, not here because video will be lengthy here. And finally we connect in the series. Series means here we connect through to the circuit so that there is only one way, and the one way of current flowing, that is all the current has to pass through the ammeter because the purpose. I hope you understood this here. That's all about the current here. How was the video? Please give it the comment box because I did a lot of work here. Please give your comment and share and subscribe here. Stay connected. Thank you and God bless you all.